So if I want to solve this thing algebraically, I want to get sine alpha by itself so that I can evaluate the inverse sine. So in order to do that, what is my first step in isolating sine?
5 sine, 2 sines by 2.
And if I do it on the left, I have to?
Make it 1/2.
So now I have sine squared alpha equals 1/2. Now how do I get rid of the squared?
Inverse sine.
I'm not going to inverse sine yet because I don't have sine by itself at this moment. So I'm going to square root. So I get sine alpha equals radical 1 over radical 2. What's my problem with this?
You have a radical in the denominator.
How do I get rid of a radical in my denominator?
Multiply by square root of 2 over 2. I mean square root of 2 over square root of 2.
Why am I allowed to do that without changing my value?
It equals 1. Wait, why can we do that?
So this fraction is equal to 1. Anything times 1 is itself. So I get sine alpha equals 1 times 2 is
2.
square root of 2. And then what happens when I multiply square root by itself?
It becomes itself without the radical.
It becomes itself without the radical, so just 2. So now I have an input of sine alpha being square root of 2 over 2. And it would be helpful if I had my whole unit circle, but I do not. So I'm realizing at this point that I did something kind of illegal in algebra.
What?
When I take the square root of something, is my answer always positive?
No, it can be positive or negative.
It can be positive or negative. So I'm just going to go back. When I took the square root here, it should have been plus or minus at this step, which means that this sine alpha should be plus or minus radical 2 over 2. Sorry.
It's okay, Miss Steele.
Thank you. Love you guys. So I'm looking for places in my unit circle where the y value is equal to either positive square root of 2 over 2 or negative square root of 2 over 2. So the first time that happens is
Power 4.
right here. Then it happens again
3
here.
power 4.
And then I don't have the bottom of my unit circle, but where else does it happen? Where?
5 power
7 pi over 4.
So my answers are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So I just answered the same problem using only algebra without graphing.
Can we do that and then graph?
Yes, you may do that and then graph.
But don't we have to find the other values that we found in the table? Or no?
It would be helpful to find the other values that you found in the table,